Hi everyone, my name is Marcos Niels. I'm all the way here from Argentina, Buenos Aires. And in this session, I'm going to talk about, as you said, serverless and Terraform. So let me share my screen so you can see my slides. There you go. You should be looking at my slides now. Slide present. Play. You present. Here we go. As I said, Marcos Niels, and I would like to make a quick introduction around the promise that containers, right, were supposed to fix at the very beginning, correct? So if we all remember when containers started a few years ago, the promise that containers were supposed to handle and to fix is basically build, ship, and run, right? So the idea is that we have an application, we need to find a way to ship, to package that application, and then to have at least the same experience that we use in our local environment and take it to the cloud and take it to our production environments. In my opinion, and this is something that I also see in other communities, is that that promise of building and shipping hasn't been really fulfilled in its entirely, basically. And why am I saying that? Mostly because right now, even though containers have been necessary in order to make this transition, the main concern that I see in this process is the fact that it still doesn't abstract the fact that developers want to ship code, right? So, and yet, in this container era, you still need to know, for example, how to build a proper Docker file. You still need to know how to create like all these, for example, I have a Docker file example here in the right. And this is something, in my opinion, like by working like lots of years in this industry, this is something that developers shouldn't be needing to know. I mean, why me as a developer should be the guy who needs to know how to create a proper Docker file for my application, for my language of choice. If I make a mistake, if I create like an image that is very big, it shouldn't be my concern to create this kind of applications. Furthermore, besides the fact that I as a developer should, between quotes, know how an operating system works, like right now, for example, if we look at the landscape of how to diagnose or how to profile an application that is actually running, I need, between quotes, I need to know how these things work, right? Like I need to know how file system works, how memory management works. So this is pretty much basically basic computer science. And now in this new container era, I also need to know a bunch of new stuff. Like I need to know how overlay file system work. I need to know how C groups works. I need to know how namespaces work. So yeah, so basically this all in all resumes to a lot of time spent in my opinion, again, technology that is not really necessary for me to ship code to production, right? So what I want to do is I just have a piece of code and I want that piece of code to be able to run locally and in production at the same time. So that's why where serverless becomes like a powerful feature, not only because of the technology involved that we all know from the major, at least, cloud providers or frameworks like, you know, AWS or Azure or Microsoft, but the fact that it allows this process to be easy for us developers. Another example that I usually use is that if you have a monorepo, for example, like in our company it's much easier in this example in this case to bundle an application that it's also a web application where I have, like in this case, a web directory and also like a backend directory, right? I could have like multiple functions in the same repo, and I could be, in this serverless world, I'm able to handle those functions directly. So the problem to basically this solution or the alternative to this problem, I mean, is serverless. So serverless is a technology that that we have it like around 10 years ago. I think AWS was the one that introduced Lambda around 10 years ago, and it's still something that it's evolving, and not so many companies actually adopted it as a first-class citizen to deploy stuff. But it's becoming more popular because of that the ecosystem is much more bigger now. It's much more prominent now, and also we have like different technologies that are actually using it. And the ability to use serverless allows you to play a little bit with these structures in the repo of your organization, right? So in this case, for example, we could have like a very basic Node.js function, like Go function, like we see here, and at the same time, you can keep it very slim, because since you are wrapping the function around the serverless framework, it could be any. You usually don't need any dependencies to run it. So this is the what is really nice about the pattern of thinking in serverless. So that's why I don't like recommending a specific technology, but the idea behind serverless, where you just have one piece of code, one piece of function, and you want to isolate that and put it into production super easily and fast. That's what I love about the technology. So in the end, what you want to achieve with serverless in general, it doesn't matter which technology, is to write at as least as possible of configuration, which is zero config. You just want to have a mechanism where you can just use push to deploy. So the idea is you push code, you deploy super fast. And these are like some other aspects that at our company were also very important, right? So the idea is that I can push a function, I can have like security immediately, and I need it to be production grade. There's a tweet about with Kelsey Hightower that says serverless. Basically, the idea of serverless is that it's going to make you like a better developer, because you are going to be focused mostly or entirely on your code, on your function, on the business of your application. And there was a nice discussion around, okay, but what's happening with SRE if my proposal or my way of doing things is actually to remove all this complexity from the middle, right? And it's interesting to see. And I also share the same point as Kelsey says here, is there's still a bunch of other stuff that SRE and infrastructure teams should also be caring about, which is basically defining SLOs and SLIs for my organization, so we can improve the business basically. So I can bring more value to the business, and I totally agree with this point of view. So in my opinion, serverless is gonna make developer and infrastructure teams more efficient, as they will only have to think about how to measure and improve the business better. Okay, so I made quite a long introduction about why serverless and what's in my opinion, also very opinionated current state of containers versus serverless and the reasons for this. And now I would like to mention how to properly handle serverless functions using Terraform to provision and to document that infrastructure in our code. So I would like to go through very different cases and very different examples. And I would like to, here's the first one. And I would like to start with the very basic snippet of how to provision a function in a cloud environment. In this case, I'm going to be using Lambda, but it could be like pretty much all the serverless providers work pretty much the same way. But I'm going to be focusing on Lambda in this case, so we can make the example concrete. So what's the minimum piece of artifact that I need to deploy a Lambda function? Usually in AWS at least, it's just a zip file where you bundle all the dependencies of your code, or if you're using like a compiled language, like a binary or something. And then you upload that artifact, that piece of code, which is the source of your code. And then you tell the platform that you're going to be running a function, a specific function of your package with some environment variables, properties, or whatever. So in this particular case, if you want to deploy a Lambda function in AWS, you just need to create a Terraform resource. You need to specify a file name. and you need to specify a function name also, and the role, which are basically the permissions that function is going to need. And you also need to specify the handler. Handler is going to be the function name, which is going to be executed that you're basically bundling into the code. And also in this case, we're using the runtime, which is Node.js, but it could be pretty much, in this particular case, it could be either Node.js, Java, Go, Python, pretty much the most supported languages out there. And then some variables, as I said, that you can configure for your function to use. So what's the main problem that we usually face when we are trying to deploy Lambda functions in production? So in this particular case, we have two problems that and one of them is going to be fixed immediately since we're using Terraform. The first one is the fact that you're going to be documenting that function. So you are going to have a catalog since you're going to be using Terraform, and then it's easy to associate that function with some other resources. So if you're already using Terraform to manage your databases, your queues, your whatever cloud service that you're already handling, to use Terraform for functions is also very good, because you're going to be able to tie everything together and then pass messages from one service to the other one. The second aspect, which is that it is the one that I would like to put some details on it, is basically how to handle updates and how to deploy those functions to production, how to handle CI/CD systems. In this particular case, if you ever started to play with AWS and Lambda, in this particular case using Terraform, you're going to see that I'm missing a particular value here that it says what happens, for example, if I apply this Terraform state resource, it's going to create the function. But then if I change the function, if I change this zip file and then I do Terraform apply Terraform plan again, Terraform is not going to see that anything changed, because I don't have a way. Terraform doesn't automatically check the checksum or like a SHA of the file that I'm submitting to the platform. So basically, it's not going to realize that the code of the function changed or the zip of the function changed. So what I need to do in that case basically is I need to specify this source code hash, which is like, this is a Terraform option. It's not like a cloud provider option that I need to specify in order for Terraform to realize that the SHA of the Lambda function payload actually changed, right? So, and this is, if you see the API, for example, of how to create a Lambda function, you're going to see that this is not here. This is not a flag of the API, but at least if Terraform allow us to handle this case where, okay, I updated the code of my function, the zip file, and I'm checking if that hash, it's the same one that is already deployed in the cloud. So this is like a very important flag to use if you're starting with this, because it's going to tell you that you have a change or not. If you already deployed a function, I'm pretty sure that you know what I'm saying. Then you specify the zip file and then you upload it again. That's perfect. But what happens now? The next step is what happens when you, for example, need to check. Going back to this example, what happens if you need to check if this payload, if this zip file has all the dependencies that you need in order for your application to run correctly? Why am I saying that? Because let's say, for example, that you have a Node.js application, and for some reason, and this happened to me in the past, if for some reason you forgot to include a dependency, you forgot to do, for example, npm install, right? So you don't have your node modules running on your bundle, and you accidentally do zip a folder. You zip a folder which has your source files but not your dependencies, and then you try to upload that into the cloud. What is going to happen is that your Lambda function is going to get created, but whenever you call it, Node.js is going to run. It's going to throw an error saying that you're missing some dependencies, and that is going to be at runtime. So unless you have a very nice or a very strict canary deployment strategy or blue-green deployment strategy, which is for serverless functions, is a different story. So we could actually make a talk out of this. You need a way to check in compile time that your zip file is going to have all the dependencies that it needs. And a pattern that we came up with and we used in the past is to use this null resource, basically resource in Terraform. And how it works here is I define the Lambda function the same way that I did in the past, but now in this particular case, I create a new resource, like a new fake resource to provision in Terraform. That is what it's going to do. It's going to use the local exec provisioner. The local exec provisioner, for those who don't know, is basically just a command that you can run locally. And Terraform is gonna complain if this command fails, and it's gonna keep provisioning if this command succeeds. Basically, when you have an intermediate step that you want to try, this strategy fits really nice. You have the Terraform documentation here at the bottom if you want to check further. But the idea here is that I have the same example that I had before about deploying this function, but in this case, I'm using the depends on clause. So you are depending on this new resource, and you are running this local exec code in order to make sure that the function deploys correctly, right? Perfect. So you have your function deployed. You are running pre-check steps to make sure that your zip file contains whatever it needs to contain. In this particular case, I'm just unzipping. I'm just listing the contents of the zip file, and then I'm just grabbing some dependency. And you can do whatever you want here. You could run any checks, but the idea here is, as you can see, to check if a specific dependency is there. Perfect. So let's jump to the one of the last steps when using Lambda functions with Terraform, that it is how to handle versioning, right? So I have my function running in production right now, and I have a way to check dependencies, that dependencies are correct. But I spoke a little bit about the problems of using blue-green or canary deployment. So the idea here is that you can use Terraform modules to deploy Lambda functions. So the idea is that you could, for example, have a Lambda in one of your as a module in one of your GitHub sources, and then you can basically name the function with the function name. And this way, if you version, as you can see here, your module using refs, right, using tags or branches or something in your VCS, then you can apply different configurations of those modules to your functions, right? So this gives you consistency when trying to handle the manifest of your function. So let's say that I have a specific version of this provider that, I don't know, allows to deploy functions with some specific configuration, like a specific reserved concurrency, a specific version of the engine. In my particular case, I'm using Node.js, but this new version has like Node.js 10, and the other one has Node.js 12. So using Git modules or Terraform modules is a very nice way to version your functions for consistency. So this is another approach that I usually like to recommend when deploying functions to production. One thing that you can do also, besides using that approach, is to use S3 as well to store the bundles of your function. And this is a good practice as well, because you can, basically you are versioning, you don't have local zip files, but you are versioning the bundles of your functions. So this is another option that I'm pretty sure a lot of you currently use, which is just upload the zip file into S3 and then tell Terraform to use it like that. What I'm mentioning here is basically all the good practices that are out there to follow. So you don't use, in this example, a local zip file to deploy. You just put it into S3, and then if you need that same zip file to do some further like diagnosis or check the code later, you can actually grab it from here. The last thing that I'm going to talk about in these last 3 minutes is how the CI/CD pipeline should look when using Lambda functions. Because right now there's a chicken and egg problem when using Lambda functions and CI/CD, that usually when you have a CI/CD pipeline, and I'm pretty sure that this happened to you or it is happening to you in your organization when you're creating your functions, you have a CI/CD pipeline, you need to deploy a function, and the first time that you need to deploy that function, you need to create it, right? So on the first run, you need to create the function, and then you have to have some sort of logic in your CI/CD system that detects that it's not the first time that you're creating the function, and then you're updating the code, because it's two different operations usually in any cloud provider. You create the function first, and then you publish code to that function. And this is not a very good workflow, because you need to have this condition in the middle. Usually our CI/CD workflow should be like streamlined, should be like, okay, I'm going to push this abstraction. I either create it and push, or I just push. So ideally what we want to have is we want Terraform to provision that function, package the CI/CD, and deploy. So the ultimate basically workflow that I usually recommend to follow this is to have like this first state in your Terraform documentation, where you just have a placeholder there, and then use the archive file resource that is going to allow you to do Terraform apply of this whole thing without having the zip file already created for your function. So you don't need to have a you can have the infra code and the application code on two separate repos, and use this pattern to basically create the function beforehand. This is basically how AWS runs functions, since I'm running out of time. And the main reason why I came up with this strategy that you see here, which is completely a personal view of it, is because if you look for in the Terraform catalog right now, if there are any Terraform modules to handle Lambda functions, you are basically not going to find a lot of them. So that's why this pattern of creating the function beforehand with this data archive, with this archive file to create the file and make it an input to the Lambda function is usually a good practice. And then you can update the Lambda function code with this snippet at the bottom. So again, just to wrap up this presentation, you want to use Terraform to handle all your serverless workflows. But the idea here is that if you're using it in your organization, you should be trying to aim to set these goals, right? To do as less config as possible, document your infrastructure, make it an easy workflow so you can just use push to deploy, and of course add security and rollouts and versioning to whatever you're using. Last, there are some other options out there. If you have any questions or you want to chat about it, like offline on the different, if you're using serverless framework or SAM or the new AWS solution to provision functions, please talk to me, and we can discuss which are better for your use case. If there are, I strongly suggest you to check this Kelsey tweet. Basically, of course, organizations are adopting serverless functions more in these last years. But in my opinion, and for what I'm seeing that is happening in the industry, is going to become like a major piece of your platform very shortly. So it's better to start documenting and using HashiCorp tools to orchestrate the functions correctly from this very beginning, because it's going to save you a lot of time and trouble. Thank you very much.